Okay, so what we're going to look at today is the basic confidence interval for a population proportion. So the question says that a company surveyed 400 people, chosen from the population of people who had bought at least one chocolate crunch bar. Of those surveyed, 324 said that they liked the new bar. Create a 95% confidence interval for the population proportion who liked the new bar. Now, when we see this question, this is a basic confidence interval question for a population proportion. So, population proportion style question from a 95% confidence interval. Now, we'll see the word 95% confidence interval and 5% level of significance quite a bit in this chapter. And when we see that, we just know that it's going to be a confidence interval question. So this is like when someone says they're 95% confident in something, that's just what we're looking at. Now, for this, we are going to have to do a interval. So an interval is between 2 and 3 or 4 and 5. So an interval is between two numbers that allows us to be confident in it. So confidence interval will always be written as p hat minus your margin of error is less than p hat plus your margin of error. Now, this is something we can learn off. This is super important. It will come up if we have population proportion or if we also had to look at a mean style question, which we'll look at in a few videos as well. So to start off this question, we are going to highlight the key terms that we need for this. So first key bit of information is, and that pen is not working. First key bit of information is out of 400 people. Second key bit is 324. And the third key bit is give your answer to 2 decimal places, just so we have our answers correct as well. And that's pretty much it. So we need to know this and we need to have this learned. Since this is a population proportion, my margin of error is going to be a certain formula. Now, for my margin of error, if I have a population proportion, we have it as E equals 1.96 multiplied by square root of p hat. Sorry, we can't see it there. So is 1.96 multiplied by the square root of p hat bracket 1 minus p hat all over n. So what we're seeing a lot in this is p hat is coming up here and it comes up twice in your formula for the margin of error, which is your E value. So how you calculate p hat is, it's what did we figure out? And what we figured out was 324 out of the 400 people. So 324 out of the 400 people in this question ended up saying that they liked the new bar. So when we type that into your calculator, you have 324 divided by 400, and that's going to be 0.81 or 81% of people. Now in this question we'll keep it as 0.81 because the question asks for it correct to decimal places. So the next part we have to do is we have our p hat, which goes here and here. Again, that's what we figured out. And we need to figure out what our E value is. Now, all we need for the E value is this formula. So I'm just going to do it down below here. So you would have that E is equal to square root of 0.81 multiplied by 1 minus 0.81 all over n. Now, n pretty much across the board in maths, and in particular in stats and probability, is the total number of people in the population, which was a company surveyed 400 people. So that would be the total number, and we put that there. Now, when we're typing this into a calculator, it's super important as well. Just to make sure that square root sign, you type maybe that button first, because that would mean that you're including the 400, which should always be included underneath the square root sign. Now, what this will end up equaling, and apologies, this will need to be multiplied by 1.96. Now, this 1.96, where does that come from? That's just because it was 95% confidence interval. So that 95%, again, it's just 1.96 multiplied by the square root of p hat by 1 minus p hat all over 4. So when we have that, we will get our answer. We can type it straight into your calculator. You will get 0.0384. And that is your value of E. So to finish off this question, I have my P hat, I have my E. We don't need that. I do have a P hat and I have E as well. So both of the sides of this are actually the same thing. Just one is minus and one is add. So let's put these together here and we will say it's 0.81. So P hat minus E, which is 0.0384, less than P, less than 0.81, plus 0.0384. And that's what we're looking at the moment. So when we get out our calculator again, we type this in, we will figure out what it comes to. So 0.81 minus 0.0384 is equal to 0.7716. Less than P, less than the exact same thing, just we add it. So 0.81 plus 0.0384, and that will go to 0.8484. Now it did say give your answer correct to 2 decimal places, so we could change this to 0.77 is less than P is less than 0.84. So what this tells us is with our 95% level of, or 95% confidence interval, we can conclude that between 77% and 84% of people did like the bar. So just adding this in now, we could be asked as a follow-up question, a company or another company or a magazine claimed that 82% of customers did like the chocolate bar. Complete a hypothesis test at the 5% level of significance to prove or disprove this claim. They might say, please show clearly your null hypothesis, alternative hypothesis. So we're just going to quickly see what that would look like. So your null hypothesis would be H0 and your alternative would be H1. Now, for your null hypothesis, you will agree with the question. So null hypothesis would be that 82% of customers like the chocolate bar. Your alternative hypothesis would be 82% of customers, so same thing again, and the difference is do not like, and so on, the chocolate bar. So again, H0 is your null hypothesis, you agree with the question, whatever the claim is, we accept it. Alternative hypothesis, okay, no, we don't accept the claim in the question, you will just add in do not into your null hypothesis. So both of these, you have to essentially try to prove one of them. So the question said a company claimed 82%, and it says the 5% level of significance. Now, when this comes up, this links directly to the previous part of the question, where we came up with a confidence interval at the 95% level of 95% confidence interval. This is what we are going to follow. That is between 77 and 84. So for P, let's fill in our claim of 82%. We'll fill that in as a decimal. So we would say that this is 0.77 less than 0.82 less than 0.84. Now, simply put, is this mathematically true? And the answer is yes, that this could be 77% is less than 82%, is less than 84%. So this all checks out mathematically, this works. So this means that we would be inclined to agree with H0 that 82% of customers do in fact like the chocolate bar. So how we would phrase this just to be correct, we would say that we fail to reject H0. So we fail to reject H0 because when I did my 95% confidence interval, that's what I was 95% sure on. I'm 95% sure that it's between 77% and 84%. When a company claimed that it was 82%, I can say, yeah, that holds up with what I found because 82 is between both of these. So I fail to reject their claim. Now, we'd also say that we accept it, but generally we tend to fail to accept. It's kind of the the correct way to say it in your leaving cert, and we're talking about statistics, we tend to not want to be 100%, so we just say we fail to reject H0. So we're now going to look at a second question, which says that a survey of 50 leaving cert students found that they had a mean mark of 374 and a standard deviation of 45. So 50 students were selected, we got the mean mark, and we also got the standard deviation. Now the difference between this question and the previous question in this video is this one is based around the mean mark. So it isn't a population proportion. It isn't saying that 25 out of the 50 students do maths or did higher level maths. So what it's saying is we have 50 students, that's your population. This was the mean mark, so this was the mean that we had, which was 374, and they gave us the standard deviation of 45 as well. So just to circle these, 50 is going to be important. It's a mean mark. That tells us the type of question. This was the mean, and that was your standard deviation. Now it says, find a 95% confidence interval for this data. So previously what we have had is we've had p hat minus e less than p hat plus e. Now, we're not going to use that confidence interval for this. That is for population proportion. What we are going to look at is a similar confidence interval, but it just has a few differences to it. So instead of it being p hat, which is what we figured out, it's now going to be x bar minus e less than mu less than x bar plus e. So x bar would mean your average, and mu would be the average as well, but a slightly different one. We're going to look at that in the second part of this question. E is your margin of error, and we're going to look at our margin of error in a mean question. So E in this case, E is going to be equal to 1.96. So again, it's the same figure coming from the 95%. It's still multiplying, but in this case it multiplies by standard deviation divided by root n. So just in case we're concerned about that, previous question was population proportion. So we used our E equaled 1.96 times square root p hat 1 minus p hat all over n. This one is a confidence interval for the mean, so we're going to use this form of margin of error. Now, just look at this question. We would say x bar is going to be the mean that we found out from the 50 students. So this is going to be given x bar. We would say that this is 374, and this is going to be minus your E less than mu less than 374 plus your margin of error. So let's figure out what we have to do to sub in for the margin of error in both these cases. We will come up to this and we'll have a look at it. So E is going to be equal to 1.96. Standard deviation was 45. Divided by n, divided by root n, which was 50. So we can see similarities between it, but since it's a mean question, it's going to be slightly different. So when you type all this into your calculator, you're going to get that the margin of error is equal to 12.473. So we're going to fill this into our formula, and we will say that the mean value was 374 minus 12.473 less than mu less than 374 plus 12.473 to give you a final answer of 361.527 less than mu less than 386.473. So what this tells us, if we were to ask to interpret this confidence interval, we would say that we are 95% sure that the average is between, that the mean is between 361.527 marks and 386.473 marks. So this could be a follow-up question that we'd have, where it says that the mean mark in one school was 385. John suggests that this is not the same as the sample in the previous question. test this claim at the 5% level of significance. So this is very similar to the previous question. We have our 95% confidence interval. So we just need to sub in our 385 into this and see if it follows true mathematically. We'll fail to reject the null hypothesis, and if it doesn't, we can look at it then as well. So our null hypothesis in this is that we're going to say that the mean merc in both of these is the same. So this is that we have the same mean merc. Now, just to be clear, we're all aware that 385 is definitely different to 375. But we want to see, is it different when we look at it from a 95% level of significance? So at the moment, H0 is the same mean merc. This is that they are not the same. And again, we're just including that word. The word not will be included, and that will sort it all. So let's say it's 361.527 less than 385 is less than 386.473. Now, is that true mathematically? Well, this is greater than that, and this is less than this. So therefore, that is true. So it'll be the same as the previous part. So we would fail to reject H0.